So in this video I'm going to do an example of matrix multiplication, and I'm also going to define that multiplication. This is a procedure that at first looks a little bit intimidating, and is one that once you've practiced it a number of times it becomes a lot more straightforward. If you have any questions about it, please feel free to come by and see me. So I want to go ahead and just give a definition of matrix multiplication. And I encourage you to, when you're done with this video, try to see how the definition fits with the actual work that we do when we compute our example. So here's the definition of matrix multiplication. We're going to start off by saying let A be a matrix. Let's say it's an m by n matrix, and let's let B be a m by, we'll say, p matrix. So matrix A has n rows and m columns. Matrix B has m rows and p columns. Then, and let's just go ahead and say with matrix A, it can be written as Aij, and matrix B then could be written as Bjk. So just following these indices, we know that 1 is less than or equal to I, which is less than or equal to n, the number of rows of matrix A, and 1 is less than or equal to j, which is less than or equal to m, the number of columns of matrix A. Likewise, in our numbering system, then we would have 1 is less than or equal to j, which is less than or equal to m as well, and 1 is less than or equal to k, which is less than or equal to p. So that's how these indices work. And so how do we define matrix multiplication? Then A times B would be denoted by the matrix C, where the Ci, see here, I want to say where the Cik entry of this matrix is the sum from I equals 1 to n, just like we said I sums, times of the sum from j equals 1, excuse me, I want that to be k equals 1 to p of Aij times Bjk. For those of you that worked a lot with double sums, I encourage you to, after this video, sit down and try to square this actual definition of matrix multiplication with the procedure we're about to do. If I lost you on this definition of matrix multiplication, that's okay. It's your first pass at it. I encourage you to keep studying it, keep working with it. But let's go ahead and jump straight into an example. So here's our example. I would like to multiply together. In fact, let me say it like this, because I'll tell you what I want to multiply after I'm done defining the two matrices. Let's let A be the matrix that is 1, 0, 3, 0, negative 1, 2, and B be the matrix 3, 1, minus 1, minus 2, 0, 2. Okay. Then the matrix AB is going to be computed this way, and what I'd like to do now is I'm actually going to color code these matrices. So there's matrix A, and we're going to be multiplying that to matrix B, and I'm going to color code these to help with learning the procedure. So I'm going to color the first row of matrix A blue, 1, 0, 3, and I'm going to color code the first column of matrix B. Well, actually, we'll just do that. Color that blue, and we'll color this orange, I guess. And let's see here, we'll color code this one 3, minus 1, 0, and we'll color code this one, I'm running out of colors, I guess we'll just do black here, 1, minus 2, 2. Okay, so we're multiplying these two matrices together, and this is how the procedure works. In the last video, we learned how to multiply a row vector to a column vector. Well, to find the new entries of this matrix, we're simply going to do row times column operations. So the new matrix, when we do this multiplication, is going to be a 2 by 2 matrix, and in fact is going to look like this. So let me make this fairly large so we can actually see the computations. I'm going to take for the 1, 1 entry. So this is actually going to have 4 entries here, and we'll see why in a little bit. This is the 1, 1 entry, and then we'll have the 1, 2 entry, then we'll have the 2, 1 entry, and the 2, 2 entry. To find the 1, 1 entry, I'm going to take the first row of matrix A, which is this column vector, and I'm going to multiply it to this first column of matrix B. This is a row vector, this is a column vector. I'm going to multiply the two together. So let's actually do that, and bear with me as I try to jump back and forth between the colors. So we're going to take 1 and 0 and 3, and we're going to multiply these two. So we're going to do 1 times 3, and we're going to do 0 times negative 1. Let me put a dot there, and we're going to do 3 times 0. And I'm really running out of colors here. I guess we'll just use black for the add. So this should look like the procedure we did in the previous video, where we took this row vector times this column vector, and we multiplied sort of like entries, if you will. For those of you that have had some vector theory before, we're simply taking the dot product of these two vectors. Okay? So that was for the 1, 1 entry. Notice there were a lot of computations to do just to get that first entry. And let's go ahead and finish that out. So if we do that computation, this would be 1 times 3, which is 3, plus 0, so that entry comes out to be 3 there, once we're done simplifying. Okay? So now let's go ahead and compute the 1, 2 entry. So to compute the 1, 2 entry, what we're going to do is we're going to take the first, because there's the 1, we're going to take the first row, the first row vector of matrix A, and we're going to multiply it to the second column vector of matrix B. So here we go. We're going to take, again, 1, 0, and 3, and we're going to multiply it to, just a second here, just lost my pen. We're going to multiply it to this column vector here, so we're going to do 1 times 1, 0 times negative 2, and 3 times 2, and those should have some addition symbols in there, so plus and plus. So for the 1, 2 entry, where we took the first row of matrix A and multiplied it by the first column of matrix B, we're going to have 1 times 1, which is 1, plus 0 times negative 2, which is 0, plus 3 times 2, and so that's 1 and 6, which gives us an entry of 7 for the 1, 2 position. So I'd like you to pause the video and try to figure out, based on this pattern, how you would set up the 2, 1 position and the 2, 2 position for the new matrices in this product. So pause the video and then resume. So for the 2, 1 position, I'm going to take, since this is we're going to take the second row of the A matrix, so that's row vector, and we're going to multiply it by the first column, 1, the first column of the matrix B. So we've got 0 and negative 1 and 2, and we're going to multiply this to 3 and negative 1 and 0. And the operation, of course, between those is addition. So actually computing that, let's see, we get 3 times 0, which is 0, negative 1 times negative 1, which is 1, and 2 times 0. Adding those up, we end up with just 1 for that entry. So for the last entry of the product of these two matrices, I'm looking at the 2, 2 position. So I'm going to take the second row of matrix A times the second column of matrix B. Just to reiterate this, when we're working with matrix multiplication, we multiply rows of the first matrix to columns of the second matrix. Okay, so we're going to have 0, negative 1, and 2. Notice the symmetry here, 0, negative 1, 2, 0, negative 1, 2. That's in alignment. Great. And now we're going to multiply that to this second column. And notice here we had a 1. Here we're going to have times 1, times negative 2, and times 2. And then those, of course, get added up. So let's see, plus and plus. Adding them up, 0 times 1 is 0. That's a positive 2. That's a positive 4. And so we get that the 2, 2 entry of the new matrix when we do the product is 6. that's a quick overview of matrix multiplication. So let's go ahead and stop the video there, and then we'll take a few minutes to talk about dimensions in the next video. Please practice this a couple times, make sure that these operations make sense.